Okay. Hello, everybody. Good morning, good evening, good afternoon, and welcome to new month, new going meta. Basically, hello, Jesus. How are you doing this
I'm
fine
doing
day?
great. Yeah. Good to see you, Alex. It's good to be here.
You too. I hope you're well. It's bright and sunny, at least here in Munich. I don't know if it's as
It, it
nice
is. It
where
is.
you
We're
are.
having a spell of sunny days, which is always welcome. No, it's
It is.
fantastic.
Yeah,
Loving this weather.
yeah.
Hope it
It's
lasts.
great. Yeah. So we moved our schedule slightly just for this month last week, and it unfortunately it fell also coincidentally with the 1st of April. So I'm sorry if you thought this was an April Fool's joke, but we actually had to really move this episode
Yeah.
because I was at KubeCon, you were at a Gen AI event, so it was too many things at the same time, and so we thought, okay,
Exactly.
can we squeeze it in sometime last week? And then it didn't really work out, and so we said, okay, let's stick to Tuesday, but move on a couple of days.
Exactly. It's yeah. I mean, these things happen, but the important thing is that we're here another month and with
Yeah,
hopefully interesting content.
absolutely. I'm already looking forward. So we discussed a little bit the topic as usual, the name of the show earlier today, and I'm yeah, I think agentic workflows for dynamic ontology selection in knowledge graph construction is another mouthful of words, I think, but it is also sounding very intriguing because if you just bridge that gap to last episodes where we said enhancing LLM tool calling with ontologies, where
Hmm.
we kind of went into this agentic flow a little bit already and embedding agentic. Uh,
There's
yeah,
so much going on that it's difficult to choose and yeah, all these things are connected, and actually more than with the last one, we're going to connect with the previous one, the series that we did on knowledge graph construction, because
hmm
that's a particularly important side of things.
yeah,
But yeah, there's two additional open fronts that we definitely have to talk about, right? So I mentioned MCP, that's everywhere these days, but I wanted to give it a bit of time, maybe the next episode. But yeah, I thought this was a good kind of continuation because the great thing is that many of the topics that we talk about here come up on a regular basis when we talk to customers, when we talk to practitioners, and this in particular is one that's been asked several times, right? Which is what happens when things are not I mean, we're going to go into that in a minute, but the idea of, yeah, you show us how nicely the GraphRack package will help us building a pipeline to take data from an unstructured document into a database if I give it the right ontology. But yeah, what if there's an element of incertitude? You don't know what's coming in the document, or what you have in your document is not in your ontology. So what does that look like? And I thought I wanted to explore that, which is something that people seem to be interested in. So let's see how
yeah.
it goes.
I mean, you know, just to latch onto that, what you just said, I think rarely what's in every document you wanna import into your data. I mean, that's why it is an unstructured
Hmm.
document. Usually they are a little bit messy. Usually you have probably a rough idea of what is in there. You have probably a rough idea of a couple of or a very good idea of a couple of documents. But
Hmm.
then if you import like thousands, millions of files, then at some point, yeah, I'm pretty sure you will have no idea
Exactly.
what's in them. Uh,
Exactly, and it goes beyond. I mean, today we're going to show it not necessarily with large documents, but
yeah,
we are now, one of the things that's super interesting, and I'm sure we'll touch in future episodes, is these agentic memory, right? So
yeah,
this long-term memory. So this idea of storing our knowledge or experience so that it can be used in different agentic workflows. And again, you're building a knowledge graph out of, sometimes it's just interactions, sometimes
yeah,
it's statements. I mean, Michael Hunger wrote a great example of an MCP implementation of agentic memory. But you know you build a graph and you want to build it in a way that then it's easy to query. I mean, not only easy, but it's feasible. And you remember the experience when you tried to do some entity extraction blindly without specifying any kind of
yeah,
schema type of ontology. Yes, you can fully automate anything, but then what you get on the other side is not that usable. So in any context, whether that's creating your agentic memory or any kind of knowledge graph, being able to kind of guardrail it with ontologies and curate and define sort of a process on how to deal with. What was the alternative to this fantastic title that we came up with? Because there's a dynamic word, but the other one was it
adaptive?
Adaptive, exactly. That's the idea. I mean, because you have to really adapt. I mean, today I'm reading about climate change. Tomorrow I might be reading about football or music. So I want to have my collection of and we're kind of already spoiling what we're going to be talking about. That's the idea. So how do we define a workflow that enables me taking control of the graph that I'm building as part of whatever process I'm doing it.
Yeah. That sounds very interesting. I'm looking forward to it. Ramona wrote a comment here, and I need to read this because it's kind of funny. You maintain the length of the title, so I think we kind of like we go with a little long titles, and we try to. We always have the idea. Okay, let's make snappy, really there, short. Everybody is interested, and okay, this sounds cool. I wanna watch that, and then we end up. Okay, this is
scientific paper style type of title, but
well, not quite that, but I think
how is that when you write a long description and you apologize for not having been able to make it shorter? So I think if I was better at giving you the initial title instead of 1 hour before, 24 hours before, maybe we can iterate and come up with something a bit more refined and more concise, because it's always a last minute thing. I mean, at least I hope it's descriptive. As
that it is for sure. So I think you have a pretty good idea of what you can expect. So I think that helps. If you if you have suggestions for us how to come up with shorter titles, we'd be interested to hear your suggestions.
Good. Okay.
But let's dive in, and it's great to see. This is one of those, as you mentioned, one of those topics where we had gathered a couple of requests or people ask for it feedback wise. So we'll pick that up. So if you have other ideas, other themes you'd like us to explore, then always put them in the YouTube comments, probably the best, down below in to this episode or any other episode. Ideally, you pick the latest one. That makes it easier for us to find them. But do that, and during this event, during the show, obviously, if you have questions, comments, put them in chat, and then we can look at those in due time. But here we go.
I assume you don't have any announcements, so we can go straight into the content.
Yeah.
So, good. Perfect. So that's a super long title. You're totally right, Ramona. So that's but we're gonna the idea is we want to dynamically select or adapt in an adaptive fashion, select the ontology that we're going to use for knowledge graph construction, right? And of the many ways in which I could have implemented that, I went with an agentic workflow using LangGraph. So that's the history of the title. But as I was saying, this connects with 2-3 episodes ago when we did kind of, I think, of sort of a series, like three of them on knowledge graph construction, and in particular on unstructured data, right? So you might remember this diagram where we said, okay, you have unstructured data, and we're going to use the GraphRag package by Neo4j to do both the text parsing, chunking, entity extraction. But for the entity extraction, I'm going to pass an ontology that kind of describes my target domain and kind of put guardrails around the graph that we ultimately are going to be putting in Neo4j, right? Because by doing that, we create a controlled and curated and queryable and usable graph. Now, that's what we've done, and it worked very well when you have one type of document or one domain of document and one ontology, right? Oops. I don't know. Let's do that later, of course. That's I'm going to go with a software update now in the middle of a. That's always, Anyway, so. Right. So what happens when I have probably less control of what unstructured data comes this way, right?
Yep.
So And basically the shortcoming here was, hey, there's a rigid mapping between the source data and specifically on the domain graph, right? So remember that's the chunking part does not get affected. So what we're doing today, and that's what I came up with the idea. And we will get to the MCP and all that, because that's super interesting. But I thought what I want to do is define a workflow, right? And effectively, what I'm going to do is, okay, let's assume I don't know what's coming this way, right? So this is my source data, and
it might be coming from users, right? I mean,
exactly, it might be
have no idea. You might have some idea of, or you have a rough idea maybe, but maybe you have users who try some things and then they upload whatever, and then you had thought about, let's say you build something for legal documents, and then you expect legal documents, but then somebody uploads a blueprint for a mechanical thing or some support, repairs things. It's kind of like very different. So
exactly, and customers and companies that we talk to they are building exactly that. So maybe it's not entirely diverse like we're going to show today, but within their domain, a company that works in the finance space, they want to give the users the possibility of saying, boom, I just drop a document here and I will get a graph on the other side that I will be able to use. And of course, it will not cover all possible cases, but if I have a catalog of ontologies and a system to figure out, what you're showing me here maps with that ontology, that's what you're going to use. So that's basically the process. So if there's some variability here, right? So I'm going to have to dynamically and in adaptive fashion pick up the right ontology. So that's the workflow that I'm describing here. So it starts here, kind of twisted, flipped it.
Yeah.
Essentially, it starts at the top, and what we're going to do, what I call extract ontology, is not really a real ontology. That's the naming that I've used. But basically, what you do first is, okay, I'm going to have a look at the document and going to do a first pass. And what I'm going to do is not really extract an ontology, but extract the key entities that are in there. So this document is a contract about buildings in cities, right? So the key entities are contracts, buildings, cities. I'm simplifying, but something like that. Okay, given the kind of the topics that are mentioned in this document, without going into very very lots of detail, what I'm going to do is, okay, I have a catalog of ontologies, the domains that I'm aware of. That can be a dozen, that can be 100, that can be depending on your business. So what I'm going to do is a lookup of the ontology. So, and I'm going to explain how I've implemented this idea, because basically what you have to do is, okay, this document is about X, Y, and Z. Which of these are closer to X, Y, and Z? And there's going to be an element of semantic similarity analysis. So there's two possibilities. Okay, I find one ontology that does cover the document and that I can use to a certain level. We can define the level of coverage, but let's consider there is a pass. I have an ontology. Okay, then I take that ontology, I pass it to my graph construction pipeline, and I will get a graph according to my controlled vocabularies. But then there's a possibility that, hey, what you're throwing at me is something that I've never ever seen before, and it's nothing in my. So in that case, what we're introducing here is kind of a workflow. A workflow like a process, right? So what I'm going to do is, okay, I know what this document is about. So maybe what I'm going to do instead is I'm going to produce a candidate ontology, and I'm going to put it in front of the user, because maybe there's a process of validation, remodeling, merging, adapting. But I'm giving you a clue of something that has come up and that I was not able to process, so that you can maybe, if you like this ontology that I've created, okay, but publish it in the catalog, and then we're ready. Or take it through the process of validation, take it through your experts, your knowledge expert, your domain expert, whatever. But you see the idea, right? And like this, we go in an adaptive fashion, extending our catalog of ontologies and picking the right one depending on the case. That's another way of not overflowing, because one could say, okay, why don't you throw all the ontologies at the LLM in the context and ask it to find the right one? Yeah, you could, but you might get to a point where that's too big, where that's too expensive, where that's additional too much work. So being able to kind of break it down in steps, that's a good approach to deal with this sort of requirement for flexibility. Does that make sense?
Yeah, that is great. That makes lots of sense. Yeah, I think that's
perfect.
good.
So little in terms of slides. That's what we have, and there's a lot of code. But I'm going to. I hope I don't need to go into all the details, but because I'll share it afterwards.
Exactly.
But I'm going to explain step by step what we're going to do. So the first thing is, okay, this is the flow that we're going to run, but this starts from the assumption that we have a catalog of ontologies somewhere, right? So let me show you what that looks like. And again, don't judge my ontologies here. I've just put 3 silly ones in GitHub, right? So there's an art ontology that you've seen before. So that's, it's an okay art. You remember the one that what defines artists, artworks. That's one that we used in other episodes. So it's an ontology that I created with, I think we created it with Web Protege or something like that, right?
I think we did with Protege. Yeah, exactly. Yeah.
There you go. So I've just put it online, and these are, we can call them micro ontologies, a small one, but this is a collection that can grow, without necessarily any limit, and they can of course link to each other. That's the power of ontologies as well. You can cover different parts that ultimately have joining points that might be certain classes. So, okay, so we have the art ontology. I've created a books ontology, which is a very simple one where I define the notion of a book, an author, a genre, a review, and a critic, and well, as always, the book title, the artist known as, the genre description. Anyway, you see what I'm going, right? And then there's a third one, which is a football one, and same. There's a notion of a football player, a football club, a football team, a city, and connections between them. So these are this is my catalog. Is a limited one, but it's let's say I decide, because I want to manage and version control, to use GitHub. Why not, right? So like this, I have always the most recent one. We can kind of track changes and version control in a practical way. So that's my list of ontologies. Now, in order to be able to do my semantic search in my catalog, I want to load them into Neo4j and prepare them a little bit, right? So let me show what that process looks like. So these ontologies are up there in GitHub. And what I'm going to go now is to my desktop, where I have, let me make this a bit bigger, and you tell me if it's readable.
That looks good to me, but yeah, that is even better.
Good. So I just, let me close everything here, because we have so much from history. So I'm going to create a new database that's just going to hold the ontologies. So I'm going to call it Onto, and this is an empty database. And on that database, what I'm going to do, like I was saying before, is I'm going to load the ontologies, right? And as you can imagine, when we load ontologies, we're going to use Semantics, and that's quite convenient. So the usual initialization with Semantics that I'm not going to go over again, because it's just creating the constraint for uniqueness and the initial config. Boom, that's run. And what I'm going to do immediately after is just load the ontologies. Here we go. So what does my code look like? So it's I'm iterating over the 3 URLs. It could be 100, it could be 700, it could be whatever. So here I'm just listing them. It could be the content of a folder. I mean, in my case, you see the football, the books, and the art ontologies. I'm passing the URLs, and I'm reading from there. And the usual request is I want to import the described in turtle format. So that's all. I mean, I'm running it, and hopefully that will not take long. So, okay, 3 ontologies loaded, not many triples, but there they are.
Super.
So now my ontologies are already loaded here, and we will start seeing the usual, collection of classes. For example, we see, remember, the artist, have the description, the comment. The artist will be connected to things like this is the a subclass. This is what is it? This is a
professional
property.
name, but
Let's put the name, because it's make it a bit bigger. So
I think that's probably
that's the properties, right? The professional name. So professional name, and there was the relationship was created that connects an artwork to the artist, etc., etc. Okay, well, the ontologies are loaded. We've done this before. Now I'm going to do one more thing now, and this all the code will be in GitHub, of course, as always. But what I'm doing in this second pass is for each one of the ontologies, I'm annotating them with the provenance. So which I want to be able for each of the elements, and you're going to understand why very quickly. So what I'm doing with this, I'm so I'm adding an additional property.
Mm-hmm.
For example, let's take the notion of an author. So I've added this property called prov, and provenance is nothing but the place where the ontology is hosted. Of course, I could have taken a bit more time and have published the ontology and use its own URI to resolve it. Didn't have time. So for now, let's use this dirty hack, which is a simple one, just the provenance. I mean, for every class, I can tell you that's defined in these ontologies. So for example, football player is defined here. So if I click here, boom, it takes me to the actual serialization of the ontology with the definition of football player. So it's a way of
I think this makes even sense. I mean, considering if you take this to a real world example, you might have your own ontology, your own, you could call it also entity architecture if you like, and you have your own mappings, and probably you might not be publishing this somewhere, but because you have your own internal structure of how things are related and how things are looking like. I mean, generally for these we take a generistic approach, but I mean, considering you're maybe looking at an internal application that assumes maybe internal documents or something, and then you have your own structure, it probably doesn't make sense, or it's probably even not really the right way to publish this outright somewhere. So you would have
absolutely structure. Yeah. So I mean, the comment was, of course, and this can be entirely, I mean, I'm using GitHub for this example, but in an enterprise context, or in a specific, I mean, it might be entirely private. What I was saying, and it's some the RDF practitioners among us might say, well, you could have used, these things have a URI. So maybe if you dereference the URI, you get to where the ontology is, and you're right. But because I quickly created the ontology, I gave them random URIs like this one. So I've not been very strict, but this could be done in a slightly cleaner way. But you're totally right. So but it's a simplification. It's just like I say, it could have been done with the namespace. I mean, these should be dereferenceable, and that's good practice when you define ontologies. But in this case, I didn't have time to do it. So that's.
I see. So that's just a question from Ramona. So you're using prof instead because we didn't have the URI is not working
exactly. It's exactly that. So I mean, I think I.
But that's fine. For
demo
purposes, it's fine.
We published, when was it? So that was my intention. I'm googling this. Just 1 second. So you might remember from many years ago, I created this post with the fashion knowledge graph, and I created an ontology. In this case, was to do semantic searches, and I defined the clothing materials ontology. And as always, I created in Web Protege. And the thing is, this ontology, I published it actually. So it worked well because the namespace, right? In this is the clothing materials basically ontology. So it's not so the URL for the things matches the URL, the physical URL, where the actual ontology is hosted. So things can be dereferenced, and that's the ideal world when you see, right, the namespace of things is matching the actual physical virtual location and identifiers becomes the same, URI, URL. So totally right. So it should have been that, but because I didn't have time to publish it, I added this provenance. But the idea is the same, being able to refer back to where the ontology lives, and keeping the link between the ontology captured in Neo4j and the original ontology published in GitHub. So that's so what do I do next? Well, we're going to search these ontology to do the semantic similarity. Remember that what we want to do is, okay, a document is going to come, or a piece of text, or some content, which I'm going to analyze. I'm going to extract the key categories and relationships, and I'm going to come here and try to find what's the most similar thing to that? Because it might not be a football player, it might be an athlete, or it might be not an artist, but a person, right? So this kind of semantic similarity, I need to enable that. So I cannot expect that this initial discovery comes up with the right term in my ontologies, because it can be very precise in my own terminology. So what I'm going to do? Well, what I'm going to do is I'm going to vectorize part of the content in my ontology. So I'm going to go over the items in my ontology, properties, relationships, and nodes, and I'm going to take the definition, the label, and the comment when present, and I'm going to vectorize it. So as we know, Neo4j supports storage of vectors and indexing of vectors. So by calling this, I'm using GenAI in this case. So I'm using the OpenAI models to create a vector out of the content that I'm selecting. And in this case, like I was saying, is the name, artwork, and the description, the comment, an artistic creation. So I'm creating an embedding out of that, and I'm persisting it in a new property that I'm going to call embedding. So if I do this quick pass, it shouldn't take very long, but it's invoking the service, and well, there you go. So it's created a bunch of embeddings. I'm going to close this, but what we're going to see is that if I look at the classes now the author is what it used to be, but now it also has an embedding that's going to enable the semantic search that I'm going to be needing. Are we good? So that's the final step, and I'm going to index that in a vector index. So I'm going to create the vector index to be able to not just compare semantically using cosine or angular distance, cosine or Euclidean, but in this case I can also do vector search, and that's what I'm doing. I've created a vector index that's called label and desc for label and description. Good. So I'm set. So I think I have all I need in my own database. So think of this Neo4j database as a repository of all your ontologies in a way that they can be semantically searched, right? Because that's exactly what I'm going to do in the next step. So that was the kind of setup. So now we have my ontology, my multiple ontologies in the graph, and then for each one of them, I can connect back to the originating one in GitHub. So with that, I can now go to, well, I forget about but I move on to my Neo4j database, which is the one I'm going to want to ultimately populate, right? So the ontology is kind of the driver, the guardrails that I'm going to use on a selective, adaptive, dynamic fashion. So let's go to the code. Am I here or am I? Here we go. That's it. And now, is this going to be readable? So it's a single class. Shall I make this a bit bigger?
A little bit, yeah. I think this is good. Yeah.
Let's take these out, and here we go. So, okay, we can. We saw the diagram before, because the diagram is actually generated by LangGraph. So LangGraph, as we've mentioned I think we touched on other. Is by LangChain, and it's a way of defining workflows, right? So you can of course have a look at the documentation, but there's pretty straightforward ways of defining exactly what we wanted to do, which is a sequence of steps, in this case in a deterministic way, and that's what made me go with this, because I really wanted it to go not in a sequence like this, but in the path that I described, and that's why I chose this framework. So why I chose this framework. So that's in it. What you will find is one thing that goes over. And sorry, what I wanted to do is show again the diagram, which I'm sorry, I'm moving from. That's the bit that I wanted to show. So so there's basically for each of the nodes in this, it's a graph, it's a directed acyclic graph. So for each of these nodes, I'm going to provide the logic, and when there's a bifurcation like this one, I have to provide also the logic, the conditional logic to go one path or the other. And ultimately, I define the graph, it gets compiled, and then I get to execute it, providing the input. And across all the stages, we pass the state, kind of the long-term, the flow memory in a way, where the state basically. So let's go back to the code, and my state contains several bits. So this is the definition of my state. So it's described in the comments, but we have the initial text provided by the user. That can be the transcript of a video. It can be the whole content of a document. This is the text that we want to analyze. I call extracted ontology is the result of this first LLM call to understand which are the key entities on my source data. Then I'm going to store the coverage of the text. So these are the entities that have been identified in the relationships. And after an ontology lookup in my catalog, I'm going to be able to say, okay, we have a 70% coverage because 70% of the classes are present, or we could find something similar or close enough, like the case that I was describing before. If we talk about a novel, but there's the notion of book, well, tick, I've found that one, right? So I've defined a threshold, as we're going to see. And like that, I can define a level of coverage. I need something like that in order to define the branching. So given a certain level of coverage, I will define if I'm okay to go on. So if you're just covering 3% of the entities in my document, maybe that's not going to be a very good extract. So maybe I want to maybe extract a new ontology, enrich my catalog, and then do another pass. So that's the purpose of this coverage, to determine if what I have in my existing ontologies is sufficient or not. And this is the collection of matched ontologies, the ones that match the document in question, the text in question, and finally the response of the user. Because I introduced kind of a user validation just to show how we can put a human in the loop there when we propose a new ontology. I'm not actually committing it in GitHub. I could have done the code, but I could add a validation step and say, okay, this ontology, I like it, boom, go commit it, and we're ready to go. Or I suppose there would be some offline sort of analysis, right? So, but anyway, that's the idea of the state. And actually, let me go all the way to the end so that you can see the definition of the graph. So here is what we define a workflow, right? And the workflow starts with the first step, which is extract the ontology, as we called it. And we can see the visual of that. So we extract the ontology, then we do the lookup. And then depending on whether the coverage is good or not, we can go ahead and do the extract, or we can propose a candidate ontology to increase the coverage, right? So that's the extract ontology. Then we look up the ontology. I'm creating nodes in this workflow. Then there's two, the extract the graph if we can go ahead, or propose a candidate ontology. These are the two optionals. And then I'm going to add the edges. So start node is where the workflow starts. And I start by extracting the ontology. Then extract ontology goes systematically to ontology lookup, which is find my semantically similar ontologies. Then there's a branch, a conditional set of edges. So if my lookup ontology, if the ontology exists, and that's my function. So in a way, if there is an ontology that matches my document, then I will say pass, and then I'll extract, or fail, and I will propose. So that's, it's pretty straightforward, the definition of the flow. We add the final edges, both the extraction and the generation go to the terminating node, and that will be the flow, right? So ultimately we compile it and we run it. This is just to generate the image, so that this is actually the image that I put on the slide. So it's quite nice to understand the flow. So and there you go. So here we invoke the flow, but actually we could run it first and then go and understand how things are happening. So I have some sentences that I've been playing with a little bit. So let me start with these first two. So there we go. So that's some text. Imagine that comes from a document. Arsenal Football Club is a club based in London, and Thierry Henry used to play for them. Right? That's some information in there that probably I kind of smell that is going to match somehow my football ontology, right? Because you remember how there were players, there were clubs, there were cities. Well, that looks like it's going to be a match. So I hope that will go through the process. It will extract entities from here. It will trace some information. So I'm going to put it down here, and we're going to interpret that and then look at the code. So if I run this, let me just run it from here. An interesting one, and you're going to see that following this kind of agentic flow, I can involve multiple LLMs, and you're going to find interesting that the first analysis is done in a local LLM, right? And that's I'm using Olama, and I'm using Gemma 3. I think that's the one, right? So I'm not printing too much here, but maybe we can see the state at the end. Yeah, the problem with that is that it's not very readable. Let me running the pipeline, and this is the final state. So I'm going to show that to you. And we can look at more details. Actually, on that, let me create a new document just to make this a bit more readable. I don't know if this is going to help. It's horrible. That's not particularly nice, but anyway. But this is the state. So we have I'm going to break it here. So first thing, so this is the text that I entered, right? Arsenal Football Club is blah, 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 and Henri used to play for them. So the extracted ontology, we call that the structure that gets extracted from this text. So it's detected that there's two categories: the notion of a football club, the notion of a city, and the notion of a person, and the relationships that it's found is based in football club and from football club to city, and used to play for. Look at it; it comes up with something entirely used to play for, from person to club, right? So that's the kind of rudimentary or preliminary sort of topics that are mentioned in my raw data. So then I go and look at my ontologies, and I find the matching ontology being, unsurprisingly, the football ontology, with a coverage of 66%, right? So that's a pretty high coverage. So that's over my threshold. So I hope that this ontology was picked and a graph was created according to that ontology. So if everything worked well and there's no errors being thrown here, I would expect to have now in my, there you go, interesting. So we have we have a football player, which is Thierry Henry, unsurprisingly, and we can expand, and hopefully it will be connected to Arsenal. It's connected to a chunk, as always, because I'm using, as you know, the club is based in London. Hang on. Oh, look at that. No, the name of the city didn't come, and we're going to try to understand why. But and they're connected to the chunk. So I was saying that ultimately the knowledge graph creation is done using our GraphRack package. And you remember from previous episodes how we can inject the ontology and giving all the guidance on, and that creates the domain ontology that you see up here, but also the lexical ontology, which is the vectorized version of the text that get captured exactly as it was, right? So good. So first check, like we did last time. I mean, we have to make sure that this is following the terminology that I used, because that was the whole point of guardrailing it with my ontology. And it's using place for, club based in. Does that match my ontology? Hopefully it does. Let me find it here. And apologies for jumping from one to the other, but that's the football one. And I think it's pretty good, right? So it's place for, club based in. So it's all quite good. Now, interestingly, we lost the name of the city, and that is because I forgot to add the property, city name or something like that. So I have a football player, I have player name, you see it's here.
The player name, club name, yeah, of course, but you don't have city name.
So, yeah, it's not a perfect ontology. It's, so the richer, and again, it's not, in some cases we have descriptions, so the richer your ontology, the more clues you give, because ultimately what you're doing here is you're giving clues to the LLM. The more clues you give it, the better job is it going to do at extracting the right model. So that would explain why we've lost we know that it's a city, but it's kind of pointless because it doesn't have a property. But anyway, that would be the reason why. Now,
well, it would. I mean, it is just an oversight. It would have property.
But let's double click on what's happened exactly, because that's I think it's worth actually going into the details. So the first thing, and here's where I'm going to probably go into a bit more detail. The first thing is the extract ontology was the first step, and this is I'm using prompt engineering here, and I'm using a local. I'll go into the prompt in a minute, but here I'm using Gemma 3 on Olama. So that's the first step, is running on a on an open source model running on my laptop. So that's a way to show that maybe for certain tasks I want to rely on my local resources, or I don't want to generate a request to a public commercial LLM for everything, or maybe I want to balance and do certain things, which is exactly what I'm doing here. So the first,
I mean, considering what we are trying to do here is that users would be uploading unstructured data, documents somewhere. They would be analyzed, and then entities would be created, or chunks would be created out of it. It makes a lot of sense to do this locally and not have people upload your,
exactly. I mean, there
business
are
secret documents up to some random
confidentiality constraints, but also costs. Also,
and also cost. Yes.
So yeah. So what I wanted to show is the flexibility of being able to do it with different ones. So what I'm telling basically this Gemma 3 model through Olama is what you see here. So analyze the following text and extract a rudimentary ontology like categories and relationships. And I want you to output these type of formats, and that's what it's producing. Like categories is a list, and relationships is from and to. And I say, do not generate any additional notes or comments, blah, blah, blah. And I give it an example. So for example, input is Cristiano Ronaldo, plays for Club Real Madrid. That's the output that I would expect. And it did a decent job, because that's and that's my prompt. I pass it. And that's what the first we saw that, right? What this had produced. So this is you see the structure here, the categories, the relationships according to the roughly the scheme. I mean, these they will be, we saw that in one of the episodes, right? They will be more or less strict depending on how much validation, and we saw how to use Pydantic for these sort of things. So lots of room for tuning here depending on your needs. But that's the first step. So I have now a list of categories and relationships. The next thing that I'm going to do, and the next step, is to go and do an ontology lookup. How am I going to do that? Well, I'm going to, the way I've approached it, and again, here, this is not very scientific method, but what I've done is, okay, I'm going to connect to my Neo4j instance, my ontology index, remember, the one that we just created, and I'm going to run a single query. So I'm going to take my categories. We can go over this query. I mean, not run it because it takes some parameters, but effectively what this is happening is, let's look what it does. So it takes the categories that we received in the previous step, right? It will say, there's a footballer, or there's an athlete, or there's a club or a city, whatever. So what I'm going to do is, for every category that I've extracted in my first pass of the document, I'm going to go and do a vector index, right? A vector index search, sorry. And what am I going to search? Well, each of the categories. So I'm going here. I'm passing, of course, the OpenAI key, because in this case I'm using OpenAI, and I take the category, I vectorize it, and I do a search. And with that, it will return a collection of close or semantically related classes. So if I search for footballer, maybe it will most likely it will give me football player. If I search for athlete, it might give me, again, football player. If I look for novel, it might give me book. So this is the kind of search that I want to get from this semantic search on the vector index. I get the best match only, and I set a threshold of 0.92. Again, not scientific. You will have to tune it depending on your experience. But I'm basically implementing some form of, hey, I'm going to look at the entities in my ontology, and I'm seeing if there's something somehow closely related to what I'm after for these. If I get it, then I aggregate the results, and that produces the output that we saw before. Where was that? Oops. Here we go. I'm just showing the coverage, but the detail I can uncover it for the next. So let me. So this runs it and returns. It's printing the result. I didn't take it, so it must be here. So the result is a bit more verbose, and where is it? So it would be this spot here, right? So it's the entities, the football description.
I think two more lines on here where it says retrieving onto.
No, here's the coverage. That's the one. So
it's the coverage. Okay, that's the lookup. Okay,
yeah, I have to work a little bit more on the and maybe I should have put a kind of a UI on top to make it look nicer, but time. So this is my lookup. I was looking for these categories for football club, city, and person. So these are the things that I identify. So and the detailed results, what I got is that for football club with a space, the best thing that I found was football club. It was not too far, so that was a close match, right? And it was found. The provenance is in the football ontology, and the score was 0.97, so it was above my threshold. So for each of these, then for city, again there was city, so that was a 0.95, so it was a good one. So in this case, it was football club, right? So that's person. It didn't seem to match person. That's well, again, we might need to tune that. But anyway, so what this gets is, and then the coverage is calculated. So 2 out of 3 didn't match the person. That's why it gives you 2/3. And then based on that, the ontologies that you need is the football one, because every single class that you found is in that ontology. So that's what this returns. And then in the next step, what we're doing, and this is not new because it's literally a copy paste of something we've done in the past. So here, this is the branch, the logic. If ontology exists, if there's an ontology that covers, basically it's based on the coverage. If the coverage is over 30%, and again we could put 50%, you choose what's your acceptable level. You go or you don't go. You pass or you fail. Okay. So in this case, I pass. And then I go with the extraction. And I was saying that this is something that you're very familiar with, because I've literally copy-pasted the code from the knowledge graph construction. So this is the simple knowledge graph construction pipeline from the GraphRag library. And all it goes is over the definition of the target ontology, which I'm passing. So all I'm doing is building the graph with the ontology. I pass it to I get the schema from the ontology. I create a simple knowledge graph pipeline, and I run it, right? So that's literally instead of passing a document, I'm passing the text that I have in my state, and that populates the graph. So that's the end of the story. And this is done using, in this case, again, OpenAI. So I have the choice of, I use OpenAI here, GPT-4o. This is the best for entity extraction. That's why I wanted to get the best quality here. But for the vector embeddings, I'm using this text embedding small model. So that's the knowledge graph construction pipeline. So another example, just to see how that behaves. So now I take another sentence, which is 1984 by George Orwell, is a dystopian novel, with Wild Pride and Prejudice by Jane Austen, on the other hand, is a classic romance and social satire. Oh, there you go. So another interesting sentence that I'm going to process. So this would be my new input. I rerun the workflow again, and you can imagine what's going to happen, right? So it's going to analyze this sentence. It's going to do an ontology lookup. Probably it's going to find the book's ontology, the relevant one, and it's going to populate the graph. Let's look at the graph to see what's happened. And we see that now we have books and authors. So let's look around, and we have Jane Austen, and we have George Orwell. As we did before, we have artists known as, and I intentionally use these kind of weird names to make sure to prove that we are kind of enforcing in a way the schema that the entity extraction step is generating, right? So that's exactly the property that we saw was being we have that. But for the book's ontology, we have the book title as the property and artist known as. So I've intentionally picked this weird name like we did in the art ontology. So it's there's a genre descriptor, and well, that's the vocabulary that we're seeing followed here. So hopefully we have, there you go, Pride and Prejudice, which is the book, and it has book title as expected. It has genre, and the genre has genre descriptor. So pretty good. So we're controlling basically the shape of our graph. And it's in this case, without me telling it, hey, now it's about books, so go and pick the book ontology, it was clever enough. Well, you know where the cleverness comes from, right? It did the lookup and the perfect match, and decided to use that ontology for that ingestion pipeline. Now, and of course the chunking as always, and hopefully the same information about George Orwell and his book 1984, that if we expand probably will be genre dystopian.
Yeah, nice.
So good job, and adaptive and dynamic. But let's keep exploring. So and happy to take questions if there's any. But what I'm going to do next is show how, sometimes it's not one or the other, right? So you can have a sentence that combines the two or multiple ontologies, right? For example, The House of Beckham is a book by Tom Bauer. It's a non-authorized biography of David Beckham, famous footballer who used to play for Manchester United. So you can see how there's elements from one and the other there.
Okay, yeah.
So hopefully, if I run this, it's going to be able to pick up both. And again, sorry about the debugging, which is not very nice to read, but you see how basically.
But that's a good example, because Ramona asked this question: what happens if two different ontologies have the same coverage for an input? Which one is chosen? So in this case, we kind of like hope it would choose the best of, or the most matching ones of.
In this case, it's complementary because they complement each other. But if that's a good point. I mean, I suppose if you, I mean, the answer is you would refine the logic for finding. I mean, in my case, I'm going, if you get to a reasonable amount of coverage, go pick it up. Yeah. If there's multiple, maybe you can have some form of weighting, some kind of what could be. I mean, probably the most recent might be one policy. The most the one with the highest accuracy. I mean, you see how I'm not using it for my selection criteria, but for all the, we saw that here, you have the score, so you can take that into account. If it's a better match, I mean, if two could cover but one has on average better scores, maybe that so there's a lot of metrics that you can pick to drive which is the adequate one to use. I went with the basic example, but you can see how that could be extended. So right, so if I keep expanding, maybe now we have this House of Beckham, which has been taken as a book. It's a biography by Tom Bauer, but hopefully there's also David Beckham as an author. He's a football player.
Yeah.
So we have now David Beckham. So there's fragments of information that are plays for Manchester United. So all good. So it picks the different bits and aligns them with the ontology that's relevant in each case. Yeah. And the final example, because I'm conscious of time and I'm being a bit too. So what if I enter something that's absolutely unrelated to what I have, and let's work for Neo4j.
Yeah.
Yeah, I was gonna go on, but let's go with something simple, right? So they work for Neo4j. So if I run that, I mean, we might be surprised, but I don't see much coverage unless they take us for artists or something like that. Or there you go. So no matching ontology was found in the catalog. So there you go. That's a proposal here. So it's giving me a proposed candidate ontology for catalog inclusion, and it tells, well, here's an ontology that describes the notion of a person, the class. There's a bit of a hallucination. Person, domain, person. It doesn't make a lot of sense. But there's an organization, which would be representing Neo4j. Organization, range, person. That's not very good. And works for is an object property with domain and range. So so you see, it's good that there's a human in the loop, because I would want to take this.
Yeah.
I don't know if it's gonna work, but I'm gonna say no here, and then the workflow ends. But I have now a new ontology, right? And I'm not saying this process is as simple as this, but I could come here and say, okay, why don't we add a new a new file that I'm going to call professional.ttl, and I'm going to paste the ontology that this has created for me. I mean, we're going to need to fix it a little bit, right? So because this is wrong, this doesn't make sense. This organization range person doesn't make a lot of sense. We might want to add some additional elements, right? Because remember that if we don't put the right kind of elements, the entity extraction is not going to work well. So we can, I don't know, we could do something like example person. We can say that's RDF. What can we say? Common describes a professional individual. In this case, we can call it, yeah, something like that. I'm sure I'm going to make a mistake because editing RDF by hand is never a good idea. But yeah, we will want to put something like a name, right? So we can say that person's name, we would say it's an OWL, it's a data type property. I'm sure I'm going to do the capitalization wrong, but that's data type. Well, I'm not going to complete it, but because otherwise it's going to, it's a data type property. I would say things like the domain RDFS domain would be X person, etc. And well, what I wanted to go, I was being hopeful that this would generate this has been Olama again, which and what, not Olama, but Gemma 3. And it didn't generate a very good ontology, but it would require, and in the real world scenario there would be some process, and we would discuss and we would align with existing ontologies. But ultimately I could push a new ontology if I get to a point where I'm happy with it. So I would commit the changes. It's a bit of a not very good one. And I have one more in my catalog. I would just need to add it to my lookup database in Neo4j, and then another pass will now pick up nicely, and we would get Alex and Jesus added as nodes with the right ontology definition. But I will stop here because it's otherwise too long. But you get I hope when people get the opportunity to look at the code to understand what the process kind of implements, which is this. Where did I put my workflow, which is probably the more visual way of presenting it. So we dynamically find the ontology, and if we have coverage, if the ontology is there to support our knowledge graph creation, we'll use it. If not, we'll create a new one. And yeah, maybe as an exercise for the next chapter, next episode, I'll close the loop and maybe commit that, validate that in some way, and put that in GitHub, something like that. But anyway, yeah, let's take a pause here, see if there's any questions, and then we'll take it from there, because otherwise it's go too long over time.
Let's go here. Super cool. Yeah, first of all, thank you very much, Jesus. Very interesting approach today. I think is a cool concept to take user input or documents, have them structured, and then you see, okay, you have probably some kind of default ontology from your company or from your domain where you work in, and then you have this, and then you have maybe some ancillaries then where they come up recently, and then maybe once in a while you have something that is out of the ordinary, and then the system doesn't quite know what to do with it. And it's probably better just to say, okay, let's stop here, because this is gonna we've seen this, right? This is gonna lead to crazy hallucinations and some weird things. So maybe have, okay, before the data we import is messing it up completely and it's going to be in a weird format, we stop here and say, okay, this does not work. Maybe somebody else needs to double check this and give it a final pass, and then hey, before we can add this data in, we will make sure that this is actually categorized in the right way. And
to be honest, if I now, today, what I would do if I was to implement something like that, what I would take is, okay, I have the kind of list of entities there. Why don't you first look how, ask an agent, right? Ask an LLM to go and say, hey, look how it aligns with the other. Is it a new ontology or is it an extension to the existing ones? Give me a description on best practices compared to existing on schema.org and some others. So I would prepare a report, because there will be a human in the loop there, right? I don't see that fully automated, but you can create a detailed description that gives the experts, or the person who has to validate that process, enough level of detail to the point that it's, I'm not saying at one click, because there will be some process there, but it would be highly facilitated, right?
So yeah, super. Okay, we had a couple of questions. We had a couple of comments on MCP, aka Model Context Protocol, where we had recently also a blog post by Michael Hunger on our blog that has been shared in chat. So I don't know if you want to say something about MCP, because you mentioned it a couple times. I think the question was, is there something we will look at integrating at some point with Neo4j?
My initial thinking is to implement that using MCP, but I thought, and yeah, we'll probably touch in future episodes, but in this case, I wanted it to be a pretty kind of deterministic kind of flow. That's why I went with the workflow, right? So do this, if that, then that, if not. So it was less of because MCP is a way of adding a very, very convenient way to add tools, to add resources, to add prompts to clients. Like, for example, there's many of them supporting it, but the one I've been testing with is Claude Desktop, right?
Okay.
So you can publish servers that offer tools and resources, and then the LLM will pick them up as it thinks that they're needed, right? And it's fascinating. I mean, it's great because it adds functionality to the LLMs that you wouldn't have, like, for example, talking to your Neo4j database, which is what Michael Hunger has implemented. And but also you have this general way of doing it, so that you don't have to write point-to-point connectors, but as long as you implement the MCP protocol, loads of applications will be able to consume it. So that's really, really interesting. It's becoming very, very popular. I'm sure we'll see lots of things coming from Neo4j on that. There's already three servers existing: the schema and cipher tools, the memory, long-term agentic long-term memory that I mentioned before, and then there's an Aura management collection of tools, right? There's another server that will enable you to spin start instances of Aura just from your Claude or from your ID of choice. So yes, I would say that we will no doubt see some stuff going on there, and I'm sure we'll touch on these.
Super. So let's stay tuned. Maybe in a couple of episodes we also talk about, but it's here at Going Meta. I wanted to we are a little bit over time, but maybe we can spend a little bit on these. There are two more questions by somebody whose username is in Cyrillic, so unfortunately I cannot read what it says. But the question is in English, so that's good. And one is quite interesting, so I thought maybe to read it out is, they ask, are there any plans to perform graph filtering before the vector search is performed to optimize the search process in large databases? Do you know if that makes sense, or if that is something?
Let me I was trying to read news. Which was the question? Are there any plans to perform graph filtering before the vector search is performed? Yeah, I mean that's entirely possible. I mean, you can enter the graph with the cipher query that does your initial selection, and it can include even full text index or just exact matches. You search for a pattern, and then you if there are vectors involved later on, you can apply semantic similarity. We have functions that can compare, do pairwise comparison. So yeah, I mean, you can do both. I mean, in this case, it's true that we enter through the vector and then we contextualize, but it could be the other way around. So that's doable right now.
Okay, super. And then final question from Carlos: will the code repository be shared? Yes, as always, we will share the repo in GitHub and our Going Meta repository on GitHub. The link to that you will see in the video description on YouTube, and that will be uploaded or updated rather in hopefully end of the week. So stay tuned. Give us a few days. If not, happens later then. And yeah, with that, I think we're at the end. I'd like to feature 2 more streams that are happening next week. I don't know if you are all going on a Easter break or not, but if you are eager for more videos, then tune in on Monday. Discover Neo4j RDB continues on the 14th of April. And on the 16th, I'm having Amy Hodler join me to talk about advanced graph rag, text, images, and audio for multimodal intelligence, a very interesting topic where you, I think, Jesus, have been joining her stream, Graph Geeks podcast, just a little short while ago. So that is an interesting collaboration where she's now joining our stream to talk about an interesting topic. And because I didn't feature it here, tomorrow, 2 p.m. Central European time, summertime, very early, as usual, unusual slot, but it didn't work out any other way. I'm having 2 gentlemen from Germany join me to talk about a healthcare life sciences graph rag application. So that is taking place tomorrow. And yeah, with that, thank you all for watching. Thank you, Jesus, for yet another very interesting episode, very interesting content. Much food for thought, I hope. As always, let us know if you are inspired by one of these episodes and build something. Share your code, share your story, either in Discord or the Neo4j community forum, or post it in the video comments. And yeah, with that, have a good rest of your day. See you around, and stay tuned. Take care.